Now that we've discussed maximum likelihood estimators both in the previous video and in class, I wanted to provide you with a couple of different examples with maximum likelihood estimators. So this video and the next video will just be examples of how we can find maximum likelihood estimators by actually maximizing the likelihood function. So in this example, we have a random sample from a continuous distribution. This density function is theta over square root of 2x, e to the minus x root x, theta root x, where the x is greater than 0, and we're going to find the maximum likelihood estimator for theta. I got a typo in there. Sorry about that. It says estimator. All right, anyway, here's the likelihood function. We take the product of the PDF, evaluated at each of the x's that occur in our sample. This is what we're trying to maximize, this likelihood function. That's difficult because of the product that we have. So to simplify things, we're going to take the log. Log turns product into sum, turns quotients into differences. So we get, when we take the log of this product, the log goes on the inside with a sum on the outside. We take the log here of this quotient, we get log of theta minus, well, we get log of 2x sub I, and we can bring the 1/2 down in front. This is a lot of unnecessary simplifying in here because of, again, we're going to differentiate with respect to theta. This has no thetas in it. This is going to go away when we take the derivative. Over here, when we take the log and e are inverses of each other, so we just get minus theta root x sub I. We want to differentiate. The derivative of the natural log of theta is 1 over theta. Again, like I mentioned before, this derivative is 0. There's no thetas. Here, square root of x sub I is just a constant, so we'll differentiate the theta, we just get 1. So the derivative of the log likelihood function is the sum of 1 over theta minus square root of x sub I. We want to maximize the log likelihood function, which means that we need to set this equal to 0 and solve for theta. Split up your sum, move the part without theta over to the other side. We notice on the left-hand side, 1 over theta, as far as I is concerned, 1 over theta is a constant. We add up a bunch of constants together n times, we just get n times the constant. So we get n over theta on the left-hand side. And again, we just need to solve for theta. So we get n over the sum of the roots of the root of the x sub i's. This will be your maximum likelihood estimator because we can check that the second derivative is negative. Again, pretty easy. We're differentiating again with respect to theta. This goes away. The square root of the x sub I goes away. There's no thetas. This becomes negative 1 over theta squared. Clearly, it's going to be negative in this case. So our maximum likelihood estimator then will be theta hat equal to n over the sum from y equals 1 to n of the square root of x sub I.